Crash Course Instrumentation presents Episode 61, Parallel Circuits, Current Division, Meter Loading and Source Sharing, Cold Open. Ever measure a circuit and watch the number change just because your meter touched it? Today we unpack current division, meter loading, and when not, to parallel power sources. Quick recap. Parallel means two common nodes for all branches. Each branch sees the same voltage. Branch currents add to the source current. Adding branches reduces equivalent resistance measured in ohms. Part 1. Current division. Plain English version. Current chooses the easier path, which means the branch with the lower resistance takes the larger share of current. Handy rule of thumb. If one branch has half the resistance of another, it takes about twice the current. What to remember? Smaller ohms, I, bigger current, larger ohms, bonus smaller current. Quick mental example. A 12-volt source feeds two branches, one at 120 ohms and one at 30 ohms. The 30-ohm path is 4 times easier, so it gets about 4/5 of the total current, and the 120-ohm path gets about 1/5. Numbers to anchor it. Total current is about 1/2 ampere, around 0.4 ampere, goes through 30 ohms, and 0.1 ampere goes through 120 ohms. Part 2. Meter loading. Your voltmeter becomes a parallel branch. A real voltmeter has a large but finite input resistance, commonly around 10 megaohms, 10 million ohms, symbol O. When you place it across a part, you add a tiny parallel path, which can pull the reading down a little. Practical rule. To keep error under about 1%, make the meter's input at least 100 times higher than the resistance you are measuring across. Example to feel it. Measuring 1 megaohm with a 10 megaohm meter will read a bit low, roughly 9% error, because the meter is now part of the circuit. Part 3. Ammeter burden and safe placement. An ammeter must go in series with a branch. Placing it across a source makes a near short and can blow a fuse. Digital meters use a small internal shunt resistor that adds a tiny burden voltage, usually only millivolts, that slightly reduces the branch current. In sensitive circuits, this matters. A clamp meter avoids insertion entirely. Loop around one conductor in the branch, never both. Use a Hall effect clamp for direct current and a standard clamp for alternating current. Part 4. Parallel sources. Sharing the load without a fight. Batteries or power supplies can be used in parallel when their voltages match closely and the design includes current sharing features. A simple method is to add small balancing resistors or diodes so one source cannot push current backward into another. If sources do not match, circulating currents and voltage sag appear. At best, the stronger source carries most of the load, and at worst, parts overheat. Battery branches work best when the cells are the same chemistry, capacity, age, and state of charge, and when each branch has its own fuse. Worked example. Safe sharing in words. 2 regulated 5-volt supplies, each rated for 2 amperes, feed a 3 ampere load in parallel. Adding a small 0.1 ohm sharing resistor to each output creates a tiny drop of about 0.15 volt at 1.5 amperes, which encourages nearly even current split. Part 5. Design patterns you will actually use. To make a non-standard resistor value, put 2 resistors in parallel. The combined resistance will be less than either one. For equal values, it is half. To spread heat, use 2 or more equal resistors in parallel so each one carries part of the power. For example, 2 quarter-watt parts acting like 1 half-watt part when the current splits evenly. For LED branches, give each LED string its own small series resistor so small differences do not let one string hog current. For sensitive sensor nodes, buffer the point with a follower amplifier so your probe does not load the circuit in parallel. History bite. Bridging the line. Early telephone circuits used a standard 600 ohm line. Test sets and recorders used bridging inputs with very high resistance so they could connect in parallel without disturbing the call. That idea, observe without disturbing, lives on in modern high-impedance instrumentation inputs. Quick self-check. If a new branch is added and everything dims, suspect the source or the wiring, not the healthy branches. If one lamp dies but others stay bright, suspect an open branch. If current skyrockets and voltage sags, suspect a shorted branch or a meter placed wrong. If a reading changes when you connect your voltmeter, suspect meter loading. Wrap up next. Next episode ties the series together with a speed solve checklist, mixed series parallel reductions, and a short challenge set. Outro. If this helped you measure smarter and design safer, subscribe so you never miss the next Crash Course Instrumentation episode. Special thanks to Tony Kupalt and the open source community for making world-class learning freely available to everyone.